Let's talk a little bit about networking. The approach to networking is quite different than in a default Docker setup. In this course, I already covered container-to-container communication within a pod that goes through localhost and the port number. I covered pod-to-service communication using node port, using DNS discovery, using the cluster IP. External to service using the load balancer, like the external load balancer on cloud. Ingress controller is also an example, or just the node port. In Kubernetes, the pod itself should always be routable. This is pod-to-pod communications. Kubernetes assumes that pods should be able to communicate to other pods regardless of which node they are running. Every pod has therefore its own IP address. Pods on different nodes need to be able to communicate to each other using those IP addresses. This is implemented differently depending on your networking setup. On AWS, it's kubenet networking, which is the KOPS default. Every pod can get an IP address that is routable using the AWS Virtual Private Network, the VPC. The Kubernetes master allocates a /24 subnet to each node. A /24 consists of 254 IP addresses. This subnet is added to the VPC's root table using the SDK. There is a limit of 50 entries, which means you cannot have more than 15 nodes in a single AWS cluster. Although AWS can raise this limit to 100, but it might have performance impact. Not every cloud provider has VPC technology, although Google Cloud and Azure does have something similar, so you can use something very similar on those cloud providers. For other cloud providers, or even on-premise, there are alternatives available. You can use something called Container Network Interface, CNI. That is software that provides libraries and plugins for network interfaces within containers. Popular solutions are Calico and Weave. Weave can be used standalone or with CNI. Or there's another solution called an overlay network. And here Flannel is an easy and popular way. There are also other solutions that I didn't put on this slide, so if you want to have a full list, have a look on the Kubernetes networking page, or just Google for CNI or an overlay network and you will get all of them. Let me just discuss Flannel in a little bit more detail so that you have an idea what it actually does. So here is a Flannel overview, a diagram. The problem that Flannel tries to solve is that, let's say you use DigitalOcean. You have a public IP and you get a private IP, but it stops there. You cannot allocate more IP addresses, but within one node, you still need more IP addresses to allocate to your pod, because your pod wants to communicate to another pod on another node. So basically, you're going to create some fake network. This is what they call the overlay network. You're going to lay a network over the network that you already have. So we have two host IP addresses here, 192.168.0.2 and 0.3. And that's how our nodes can communicate with each other. Our pod also needs an IP address, and here we're going to use some virtual IP address that is going to be managed by Flannel. Flannel also uses etcd as a backend to store its networking information in. So 10.3.1.2, the IP address of our pod of node 1, is going to go to Docker 0, which is the gateway, which is then going to go to Flannel and then to the host IP. And if you would take a look at the packet that is transmitted between host IP 1 and host IP 2, so the one with .2 and the one with .3, is that the packet is encapsulated, because the source and destination always need to be the 192.168.0.2 and 0.3 IP addresses if you want to send a packet from point 2 to point 3. You cannot communicate the IP addresses 10.3.1.2 or 10.3.2.2 over this real network. So those are encapsulated within this packet. So that encapsulated packet goes then to the host IP, Flannel 0. It actually gets to a normal packet again and goes then all the way to the other pod. So Flannel acts as a network gateway between the nodes. So you're going to have an overlay network so that you can assign each pod with a unique IP address that is not really known by the real network. That's it in a nutshell. So if you're going to deploy your Kubernetes cluster on-premise, on cloud, but not AWS, Azure, or Google Cloud, then you might need Flannel. For instance, for DigitalOcean, you need an overlay network. You can use a CNI like Calico or something simple like Flannel. Often when you're using some launch scripts that are going to deploy your Kubernetes cluster for you, those launch scripts will include the configuration for software like Flannel. But it's still very good to know that this exists and that you might have to implement it yourself if you're doing, let's say, a manual setup.